This video presents the 2021 to 2022 3D VAT Pump Integration Project by Abigail Olson, Devin Elliott, Abdulaziz Ahmed, and Nolan Van Den Einde. SLA 3D printers are one form of additive manufacturing. They work by using a laser directed into a vat of liquid resin to cure a 3D shape, layer by layer. This project is designed to solve one problem noticed with creating 3D composite materials on an SLA 3D printer. Over time, the fiber reinforcement, such as aluminum and copper, sinks to the bottom of the vat. This happens because the fiber is denser than the resin it resides in. Thus, the resin in the vat must be recirculated constantly so that the dense reinforcement can be added to the resin and be continuously suspended to print uniform composite materials. This project involved the modification and use of the MOI 130 SLA 3D printer. The team had the following constraints to apply to the project. The printer must be easy to handle, assemble, use, and clean, feature tubing that will allow proper flow of the resin, feature a pump that can handle a viscous liquid, and feature a nozzle design that maximizes fiber distribution. The first constraint fulfilled was finding a pump that can handle a viscous liquid. Once the pump was found, it was noticed that the pump was too big to fit with the current arrangement of the printer. This led to three designs being created: an outside attachment of the pump to the printer, a modification to the original printer frame, and an under-the-printer pump housing. The under-the-printer housing design was chosen for its lowest vibration effect on the laser, as well as its ample space, making it easy to handle, assemble, use, and clean. In parallel with concept design, a nozzle design was created to provide ample flow throughout the vat during a print. To prove the success of this nozzle design, a CFD analysis was completed. To do this, a flow rate test was completed on the pump with both neat resin and copper resin mixture to find the flow rate the pump produces through the tubes. After CFD was completed and the nozzle was optimized to maximize fiber distribution throughout the vat, the final design was 3D printed. Once parts arrived, frame bars were cut to size and walls were modified to include a door. Then the under-the-printer housing was assembled. Finally, all aspects of the project were compiled. The printer and pump housing were connected. Tubing was routed from the pump to the printing vat, and nozzles were placed on the vat. In the future, 3D print testing shall be completed without the pump and with the pump to prove the success of our design. We would like to acknowledge the following people for their help and contribution to the success of this project: course instructor Dr. Ali Amiri, manufacturing assistants Rob Saylor and Francisco Valenzuela, graduate students Atik Rahman and Thomas Springler, and funding via the Army Research Laboratories.